Yay, happy Monday. We have one last test to learn, just one. It's fantastic. Alternating series test, and alternating series test is a really nice one to use as well. So the first thing is, what is an alternating series? An alternating series has to go directly back and forth with positives and negatives. If it goes positive, positive, negative, negative, positive, positive, negative, negative, it's not an alternating series. It must be that it changes sign each and every time it goes to a next term. Now, if you can imagine, if you add, subtract, add, subtract, add, subtract, that increases your ability to converge. And the alternating series test is, you're looking at B sub n as being the absolute value of the formula that you have. So you are given a formula, and B sub n is the absolute value. It's only the positive terms. And that's why in the formula they have it written as plus B1 minus B2 plus B3 minus B4 and so on. It does not have to start on the positive, it can start on the negative. And all you have to do is, once you state that you have an alternating series, take its absolute value, and two things have to happen. And I would advise that you check this one first. If you find that the absolute value of the terms are not heading to zero, you're not going to be able to use alternating series test, because this only shows you that you have a convergent series. That's it. If this limit is not equal to zero, then you're going to be able to turn to the nth term test for divergence, and that one will tell you that you diverge. But notice there are two situations. So I just want to make sure you're clear that if this happens, then turn to the divergence test, which is referred to as the nth term test for divergence. Now, realize that what this is saying is that the sequence is at least non-increasing all the way through. And I will tell you that the only time that I have seen problems where we are getting zero for the limit, but this is not happening, is when you're actually dealing with a double formula for one series. So know that that's the only time I've ever seen that occurrence. And let's do an example. I'll come back to this picture. And we're going to start off with if we have an alternating harmonic series. Now we know that the harmonic series itself diverges, but the alternating harmonic series, let's see. Here's what you must write down. You must verify in writing, acknowledge that this is an alternating series. Then you need to express the formula for the absolute value of your given formula. Now, to be like officially stating exactly what the theorem requires, you're going to take this formula, plug in an n plus 1, and then just have the formula with the n. So what I'm looking at is, this is b sub n plus 1 and b sub n. I want to be able to say that it is less than and possibly or equal to. In this situation, if we're making the denominator bigger, we are definitely as a fraction smaller. I don't have to write the equal to sign here because the less than sign meets the requirements of alternating series. If you want to put the equal to sign in, that's fine because it is still a true statement if you include the equal to sign. But you can do it either way. You don't have to express that you know this inequality is true. Just state it. Then the limit as n approaches infinity of 1 over n is 0. Now be careful because what happens is you start using a variety of tests and you begin to kind of mix and mesh them incorrectly. Remember that if the formula here is the entire a sub n formula, which this isn't, but if it was the entire formula, this would not be enough. This causes people to accidentally start thinking that with the nth term test for divergence, getting equal to 0 is enough to say converge. But be careful, and I'll show you the tests and remind you of this issue, but make sure that you are consciously aware you are doing alternating series test while you are doing alternating series test. So at this point, you have met the requirements. You have an alternating series, the absolute value of the terms are in the correct inequality, and the limit is 0, you converge. And a lot of people will just write AST for alternating series test. And over here from the textbook, they give a lovely picture of the terms themselves being positive and negative. And the x-axis is n, just the position in the series. And what I want you to see is that the sum is going back and forth and back and forth because you're going to add and then subtract and then add and then subtract and then add and then subtract. And if you keep adding and subtracting less and less, and you are heading to 0, and you continue to add, subtract, and you must not increase and head to 0. I want you to logically see why you would have to have converging for your alternating series under those two conditions. I want you to also notice that wherever that sum is, you're bouncing back and forth between being bigger than the sum and smaller than the sum. And what that actually creates is this picture, which I want to point out to you because this is a very, very, very important picture. This picture runs under the assumption that we're starting with a positive term. We could create a whole nother diagram for starting with a negative term and we'd get something very similar. But this is a really nice picture example to help you understand something. Let's say I find the nth partial sum. Let's say I find the fifth partial sum. The fifth partial sum is a positive b1 minus a positive b2 plus b3 minus b4 plus b5. And let me make sure to clarify that if I'm dealing with, say, -1 to the n minus 1 of, oopsies, there we go, b sub n, then I could also, in other words, say, this is the sum of a1 plus a2 plus a3 plus a4 plus a5, where the a's have the negatives involved and the b's are the absolute value. So you've got the sum of the first term, then You take away less than you gained, and you get the sum of the first two terms. Then you add on from there less than you just lost, and you get the sum of the first three terms. And then you take away less than you just gained, and then you add on more than you just lost. I'm sorry, less than you just lost. And what I want you to see is that every time you bring on another term into that series, you cross over whatever the actual sum is, because that S right there represents the actual sum. And it will keep playing a game of tennis back and forth. In fact, think of it as a game of tennis. If you land in your court twice, you lose. This will never land in its own court twice. It goes one court, the other court, one court, the other court. And imagine that it's this crazy tennis game where you have to get closer and closer to the net and still have it always bounce between one and the other. And again, where that net is the sum. Now, also very important to take a look at. If I'm sitting here at S sub 5, whoa, look at how far I am from my actual sum. And then realize that the distance it's going to take me to get to my next partial sum, that distance is greater than my current distance to the sum. Know that we're going to come back to this. We will come back to this. And you're not even doing homework on this today. I'm saying this for the first time today so that when I say it later, it will have had some time to sink in. And that is the following. The error of an nth partial sum of an alternating series, and by error, that's meaning the distance that that partial sum is from the actual sum. So I'm going to put that as a little note. This is the absolute value of your nth partial sum minus your actual sum. Is no more than the absolute value of the first omitted, and I always forget whether it's two M's or one. I think it's one M. That looks wrong. Term. Period. This is a phrase you want to actually get used to for the AP test. The error is no more than the absolute value of the first omitted term. Now, by first omitted term, let's go with green. S sub 6 is the sum of my first 6 terms. To go from the sum of my first 5 terms to the sum of my first 6 terms, I have to go a distance of B6. So that means that if I have added the first 5 terms together, the absolute value of my first omitted term is the positive value B sub 6. Again, this isn't on tonight's homework, but I want you to start getting this thought in your head so that it's easier when you do see it. Now, we are ready for a next example. Yay! And everybody's still there, right? Unfortunately, to see you, I have to go off this screen. And it just feels so weird talking to an empty screen. I am still on with you, right? That's my paranoia kicking in. Okay, good. All right. It just feels really weird to not be able to see anyone. All right, here we go. Next example. So you're going to look at this and go, oh, hey, look, it's a cute little alternating series. Yay! And so you say, hey, it's an alternating series. And then you head right into the test and you're like, ooh, the absolute value of that formula is this. Oopsies, there's a minus there. And then you have to determine that this is decreasing and the limit is heading to 0. And do you see a problem? Both of them have to be true in order to conclude that this converges by alternating series test. I think it's easiest if you look at the limit. The limit of the absolute value of the terms is 3/4. It's not 0. And can you see that if I plug in n plus 1, this subtraction in the denominator, well, wait a minute. Actually, regardless of whether it increases or decreases, the fact that this limit is not 0 is a deal breaker. Alternating series cannot be used. That means this test fails. Whoops. Test fails. What does that mean? That means all the work you just did was completely pointless unless it's like a problem that asks, why can you not use the alternating series test? If you are explaining why you know this series converges or diverges, you cannot use this test as part of your explanation. So it's back to the drawing board. That's like waiting in a 2-hour line at the DMV and finding out you're in the wrong line. And they say, I don't know what line to go to, but this isn't it. And so you search for another line. And know that most of the time, you can turn to the nth term test for divergence. However, when you do that, you're writing limit again, but you need to write a limit for the entire formula. The nth term test does not look at the absolute value, it looks at the entire formula. Now, unfortunately, that makes it difficult to say the answer to the limit, because the answer to the limit is alternating, or you might say oscillating, between 3/4 and negative 3/4. Now, what do you need to say? Really, you just need to say that this limit does not exist. And if you feel like you want to be precise about why it's a does not exist, you can express this. It's an oscillation. And do realize that oscillation doesn't automatically mean diverge, because with an alternating series, you actually do have an oscillating situation. So let me go back to the picture that I showed you a wee bit ago. If I can find where it went, I apologize for making you dizzy. For this one, you do have that you are oscillating, but you are oscillating toward one number. A does not exist limit due to oscillation is oscillating between more than one number, and it's not picking a number to head to, a single number. So at that point, you would say diverge by that test, and that's it. I got one more example for you. And at this point, are you seeing that alternating series test is actually pretty fun? It's quick. It's easy to recognize. Most of the time, I should say. So remember, when you notice it's an alternating series, first state that, recognize it. And then explain the absolute value of the terms. And then you're going to take that formula. You do not have to explain how you know that plugging in n+1, whoops, that was a squared. So replacing the n's with n+1s, that is going to be less than the nth term. In other words, each next term is smaller than its predecessor. And then state the limit as long as the limit is what you need it to be. And it's only for the positive formula that you are checking. With these two being true and knowing it's an alternating series, you are ready to say converge. And often we abbreviate it with just AST, alternating series test. Okay, now I do have the video going right now. So that's just a warning. I need to switch over to take a look at you. And I also saw a question, a series where the divergence test limit approaches 0 and the series is not convergent. Actually, the harmonic series itself is one that does that. The harmonic series does decrease, or sorry, it does head to 0, but it diverges. And I am looking for this. Did that answer your question? And let me check. Okay. And back over here. Now you have all the tests. Ah! So let me clarify for you what you now have. When you look at this second column, that's an explanation of what is necessary to happen if you're going to get a converge. If it is a blank spot, that means you cannot use that particular test to determine converge. So that nth term test for divergence is a divergence test. And these are the conditions under which it will diverge. And keep in mind that if you do get a limit of 0 for the full-blown formula, This test just says inconclusive. Find another test. So I will say again that I consider that like the person at the door of a club deciding who is good enough to get into the club. And if your terms are not at least heading to zero, they probably laugh at you and turn you away because they're like, you don't even head to zero in your final terms. How do you think you're going to converge to a real number? Come on, don't bother us. Something like that. And I want to point out the blank spots because that is very important. We have a blank spot with harmonic series, but harmonic series is just plain, all you have to say is I have a harmonic series, it diverges. There's nothing about converge with it. But I want us to keep looking for those blank spots because it's very important. The alternating series test is blank for diverge. It cannot be used to prove divergence. You might try to use it on the way and find that it fails. But if you need to explain how you know something diverges, you cannot express the alternating series test. It was just a flat out fail. So again, inconclusive on the right column, and that's very important to take a look at what is inconclusive with each test. And keep in mind, if you're doing one of the two comparison tests, the direct comparison test requires the inequality to be in the proper direction. So just here it just says that the inequality is not in the necessary direction. For the limit comparison test, if you are getting an answer of 0 or something that is infinite, that test is inconclusive. It cannot be used. And now with the alternating series test, we have inconclusive if even just one, doesn't have to be both, just one of those doesn't work. And then lastly, don't forget with the ratio test, if you get an answer of 1 to that limit, it just can't help you. It says go somewhere else. Now, the exciting news is tomorrow we're going to just take a look at a whole bunch of series and decide what's my best approach as far as what test should I turn to, because that's always the biggest issue of pulling this all together and trying to decide what test to go with. So I'm going to guide you with that tomorrow. And in the meantime, I'm going to stop recording